Now in mathematics we have expressions, and we want to see the different relationships between these different expressions. The main relationships that we're going to be concerned with are with the equal sign and inequalities. That is, things that are not equal, we can compare them and talk about when one thing is greater than another or less than another. So for example, we could say, okay, here's an expression, 2 plus 3. We could compare that to 1 plus 4. Those are each expressions. In fact, we say that they are equal to each other, since 2 plus 3 is 5 and 1 plus 4 is also 5. We could even continue this and say that it's equal to 5. Or we could write something like 0 plus 5. Each of these individual expressions are equal to each other. Now, if we want to compare something like just 5 and 2, well, we know that 5 is larger than 2. And so to express that in math notation, we use this inequality here. That means larger than, or we say greater than. Now that's when we're reading our expression from left to right, just like we normally would. Then we could look at comparing the 2 with the 5. So that would be writing the 2 first and then the 5. And if we're looking at this from left to right, we would maybe say 2 is smaller than 5. Or we say less than. And that's the notation we use. So this reads 2 is less than 5. We could also say that two things are greater than or equal to each other, or less than or equal to each other. If we want to say greater than or equal to, we would use the same inequality for greater than, but then we'll throw this line under it for the equal to part. Similarly, if we want to say less than or equal to, we'd use the less than symbol and put a line below it to represent the equal to part. Let's compare some more quantities. Consider 1/2 and 1/3. We could look at those as fractions, but we could also look at them as meaning division. So we could see 1 divided by 2, or on this side we could see 1 divided by 3. Now if we have the one thing, or one candy bar, to split amongst 2 people, if we compare that to 1 candy bar split amongst 3 people, we know that splitting among 2 would get us larger pieces here. So we put the inequality, that means greater than. One way to help you remember which way the inequality should face is that it's going to kind of open up to what's larger, or you can picture like a little alligator mouth. It's going to open and get the thing that's larger. Now if we want to compare, let's say in general, if we have a, or a is a variable, divided by 2, and compare that to a divided by 3, this follows similarly from above. Instead of ones, though, we're talking about some number a, some positive number a. Since we're taking that a and dividing it by 2, if we're going to compare that to a divided by 3, we're still going to have larger pieces. So when we take the same quantity and we divide, if we divide by a smaller number, we will have larger pieces. Now let's look if we change our numerator. So in other words, let's look if we have 3 over b, comparing that to 2 over b. Now this time we're going to be dividing by the same number. So if we start with something larger, 3 things, and divide by the same number as we do when we have 2 things, we know that we're going to have still more. Let's see if we change this a little bit. If we look at c plus 3 compared to c minus 2. So first, if we're considering that c is a positive number, if we add 3 to it, it's going to be larger than if we subtracted 2 from it. So we'll make this greater than. Now let's look at some fractions. If we have c plus 3 over b and c minus 2 over b, since these are the same numbers in our denominators, that means we're dividing by the same number. So what we're most concerned with is which numerator is larger, which c plus 3 is larger. So that means c plus 3 divided by b will be larger than c minus 2 divided by b. Similar to equations, we could have a string of equalities. We could also have a string of inequalities. So for example, if I want to have something like 7, and I want to compare that to 4 plus 2, well, this expression has a real value of 6, so I'd say 7 is greater than 4 plus 2. But then I can compare that to more things. What if I wanted to compare that to, let's say, 5 minus 1? Well, 5 minus 1 has a value of 4, so it's still going to be 6 is greater than 4. But when we have this string, we also get from it then that 7 has to be greater than 5 minus 1. So it has to be true even if you take like the middle section out. So if we throw some variables in here, let's look at this expression, d plus 5, and how it compares to just d. Well, we have, both of them have a d, but then this is 5 more, so this is going to be larger or greater than it. Then we can also compare d to something like d minus 3. Since we're taking 3 away from d, that means the d would for sure be larger. That gives us then that d plus 5 is going to be greater than d minus 3, which we've kind of seen that already before. Let's try and compare a few more fractions here. F over 0.1, we want to compare that with f over 0.01. Since we're taking the same amount of things, and then we just want to see what's going on with our denominators. Well, 0.1 or 1/10, comparing that to 0.01 or 1/100, we have 1/10 is going to be larger than having 1/100. So if we take the same quantities and we divide by something larger, we know that we're going to get that f over 0.1 divided by f over 0.01 would be less, since we're dividing by a larger quantity. We can also look at something one more time, f over 0.56, comparing that to f over 0.23. Similarly, we have 56/100ths here and 23/100ths there. So if we want to divide by fewer or by a smaller number, and again, notice that our numerators were the same, then we know that f over the 23/100ths would be larger than the f over 56/100ths, or in other words, this is less than f over 23/100ths. So we can conclude here that dividing by a larger number results in fewer pieces than dividing by a smaller number. We also have that dividing something larger amongst a group will give larger pieces than dividing that same something